So we are going to work on what we call hypothesis testing for population mean. So what's the difference between population mean and population proportion in terms of testing is that what parameter we are looking at in terms of its explanatory variable, right? So what kind of parameter are we looking at in here? Tree? Quantitative, right? So can anyone give us any level of measurement or parameter that has a quantitative level of measurement? Height, very good.
Really thinking the
Distance.
same thing.
In here we have what we call ACT scores, right? So anything that has any variable that puts meaning into a certain value, then that's what we call quantitative parameter in terms of level of measurement. Okay? Right. Before we continue, so we're gonna follow this flow chart, which you should be familiar with already in terms of confidence interval, because definitely the question is, how do we know if we're using hypothesis test for proportion or hypothesis test for population mean, all right? So what's the first step? What's the first condition, Mason?
Parameter is quantitative.
Right. If it's quantitative, thank you, like height, ACT scores, weight, credit scores, anything that puts value, meaning into a certain value, then that's a yes, then we can continue, right? However, if it's not quantitative, that means what are we gonna use, Robbie?
Population proportion.
Thank you, right? The P, right? The population proportion that we have done yesterday, all right? The Z-score and the proportion statistics. Anyway, well, we are not guaranteed yet that we're gonna use what we call t-test for such, right? It depends on two conditions. And what are those two conditions for this, Brett?
Random sampling and n is greater than or equal to 30.
Thank you, right? Is the sample size big enough? Did we do a random sampling? Okay. If yes, then we can use our hypothesis test for population proportion, population mean, which is what we call our t-test. And later, it's basically StatCrunch. We're also going to consider the manual computation for that, wherein the t naught or t sub 0 is equal to the sample mean minus, what is this again? Population mean, very good, right? All over, what is S by the way?
Sample standard deviation.
Standard deviation. Very good, over square root of sample size. Very good, okay? So again, sample mean minus population mean all over standard deviation of the sample over square root of the sample size, okay? Now, again, if it's quantitative, if there's random sampling, if the sample size is greater than 30, then yes, we can use our t-test, okay? What if it's not? What you're gonna do? Let's read this one in here. Abigail? It's
population of normal distribution.
Thank you. If the sampling, thank you for that, if the sample came from a population that in the first place is already a normally distributed population, then that means you can still use t-test. Once again, even if your sample size is small, if it came from a population that is guaranteed, mentioned in the first place, that it is a normally distributed population in the first place, then you can still use t-test. Again, even if the sample size is smaller. Okay. What if it's not? Again, there's always a yes or a no, right? What if it's not? Then, let's see in here what we're gonna do. Angelina?
Assess normality.
Thank you, right? Can you recall our assessing normality? That QQ plot is one of them, all right? So basically, you do your StatCrunch and see if that regression correlation turn out to be what? Less than, right? The critical value according to the sample size, then you can still use t-test. Again, What if it's not? Once again, then you can use other alternative methods like bootstrap. We can also use the binomial probability if it doesn't guarantee a normally distributed. The only summary in here is that we have to guarantee that the sample is in the first place normally distributed, and there are different ways of checking into that. Okay, either sample size, the shape of its population, if it's normally assessed as a normally distributed. Other than that, then we can use binomial distribution for such. Now, what if it's gone? What if we can use t-test? What if we can use t-test? What do we do then? Let's read the step number 2. All right, Emma. Oh well, Emma is not me. Caroline.
Hypothesis. Alternative hypothesis
And?
alpha or confidence interval.
Thank you. Right. So typically the alpha once again is our what's that? Alpha is the if confidence interval is say 95%, then alpha is what? Level of significance, the 0.05, right? That's the tail end. Very good. They are what? Complementary, right? They typically would complement. Yeah, they would typically add up to. Well, definitely add up to 100%. Very good. Okay. Again, either you're given a level of significance or a confidence interval. Either way, you can use t-test for such. Okay. Next, step number 3. Let's read that one. Obi, go ahead, please. Yeah.
Compute to or use StatCrunch.
Yeah. It doesn't really look 2, guys, right? But it's a t sub 0. Sorry. Okay.
Oh, my fault.
So t sub 0. No, actually, it's my fault because the writing it actually does look like t o, which is honestly it's 2, right? But it's t sub 0. Or again, we can use our StatCrunch for that. Again, honestly, you just use StatCrunch. If you want to use manual computing, then you can use this. Okay. Next one, step number 4. What do we do for that? Jace, go ahead. Is
P-value less than
alpha. Thank you. Right. So again, the level of significance. Okay, the level of significance. If the p-value that you got from StatCrunch is less than that level of significance, typically it's what? 0.01, 0.05. Definitely 0.01 is much stronger in terms of its confidence, right? In terms of number 5. Let's read in here. What do we do? Last one in here. 3.
Conclusion and interpretation.
Thank you, right? So, with a conclusion interpretation, you're gonna do what? Do you reject the null hypothesis? Do you not reject the null hypothesis, right? And what's the interpretation of that, right? Is there sufficient evidence to support, the null hypothesis or alternative hypothesis, or is there insufficient evidence for such cases? But anyway, let us use that technique for this one, all right? Let's read this one and see how we can work on this one in here. Let's read this, okay? Click it in here and let's see it in here, guys. What do we got? Thank you, Brittany. Go ahead, please. Are we ready for college? Well, we're already in college, right? Okay, go ahead. ACT, the ACT. Number 13.
The ACT is a college entrance exam. ACT has determined that score 22 on mathematics portion of the ACT semester.
Thank you. Okay, so that is our case. Well, before we start with letter A, stating the null and alternative hypothesis, let's analyze this condition first, right? First of all, what is the parameter that's need to be measured for such? What's the explanatory variable? What's the parameter for this? Anyone? What are we trying to measure?
ACT scores above 22.
Very good, right? An ACT score. So it's quantitative, right? So not the entire general ACT score, but the ACT score of the math portion. Okay, so if you have taken ACT, there are different portions of that, and math is one of them. Okay. Anyone who can tell us like what the other portions of ACT is other than math? Those who just took ACT. Reading. Do we have reading for that? Yep. Very good. All right. That's correct. Well, so again, this is just for the math portion. So yes, it is quantitative. So check on that. Check. Next, let's see. Did we have a random sampling?
Yes.
Check. Right.
Check.
Very good. Random sample. Right. Crystal clear. Right. Random sample. Next one. Sample size. What can you say about the sample size?
It's a lot greater than 30.
A lot greater than 30. Very good, right? So, can we assume normal distribution from that? Yes, right. Very good. And once again, what is the theorem related to that? Why are we assuming normal distribution even if we don't know what the shape of the population of this particular case is? Central limit theorem. Very good, right? So, by again, central limit theorem. If there's random sampling, if the sample size is big enough, it doesn't matter. It doesn't matter what the population shape is. Skewed to the right, skewed to the left. It doesn't matter, right? Your sample distribution will be normally distributed, right? And by the way, I have just read. I don't know when this one was. That the word what? Regardless. Irregardless, they're both accepted words, right? Okay, get what I mean? Right? So, because in the past, they don't consider irregardless as an actual word with a meaning, but right now, I think they have seen some historical basis of the word irregardless. So, cool. Anyway, continuing. So yes, we can use t distribution, then we can proceed now step number 2, right? Let's read letter A and answer that one, okay? Juliana, go ahead please.
State the appropriate null and alternative hypothesis.
Thank you, right? HO, HA. Alright, so what do you think is our HO and HA for such? And again, the HO and HA will also tell us what kind of test are we using. Are we using two-tailed, left-tailed, or right-tailed? Okay? So, what do you think is the null and alternative hypothesis for such? Well, first, what do we consider using? P, mu, or sigma? Hint. We have the word
Mu.
mu. Very good, right? Very good. There you go. Okay.
Uh-huh.
Okay. Now, is equal to, what's the stated mean for that?
22.
22, right? It is said, right, that typically, right, based on research in the past, 22 means that they're ready for the math college part. Okay. What is your alternative hypothesis? Are they scoring what? Above 22 on the math portion of the ACT. So what's your alternative?
Greater.
Greater than 22. Very good. So with that being said, are we talking about a left tail test, two tail test, or a right tail test?
Right tail.
Right tail test. Okay. Also, let's put in here what's your alpha or level of significance for that. Did it mention to us what the level of significance is? It's actually on letter C, right? What did we say in there, letter C? 0.05 level of significance, right? Typically, once again, if it's for like educational purposes, the level of significance is typically on that range, 0.05, right? But again, if it's like a medical purposes, it's on a higher, it's a much stricter range, like 0.01, okay? Because you want to lessen what we call the type 1 error, what we call the, again, error of rejecting the null hypothesis even if it is true, okay? Anyway, going back in here, let's read letter B for this one. Giselle, go ahead please, verify. Thank you, okay? So once again, our mu is the population mean and it's quantitative, right? Okay, so that's next one. What's the it's a random sample, right? And what is your n? Equal to 200, right? And we know that 200 is what? Greater than 30. So yes, by central limit theorem, we can assume normal distribution for the sampling, and yes, we can perform t-test for such. Let's read letter C for this one, all right? Mia, go ahead please. Use the classical.
Use the classical or p-value approach at the
Yeah, alpha 0.05.
0.05 level of significance has no hypothesis in RA.
Thank you. Okay, so with that being said, let's see first what our what is this? What our t value is. So what's our t value for this? T sub 0. This is by manual computing it. Okay. What's your x bar? What's your sample mean?
22.
Mean of the sample. The 22 is the what? Mean of the
Oh,
population. Very good, right? So this is the mu, right? So that's the mu, that's 22. But what is the mean of the sample out of 200?
22.6.
22.6. Very good. So this is your x bar. Okay. So notice the difference, guys, for that. And again, which means that your t value here can also be negative. Okay. That is if the does it look like 3? It should be 22.6. Okay. If the sample mean is bigger than the population mean, then definitely it can be, well, sorry. If the population mean is bigger than the sample mean, then it can be negative, right? What's your S? What's your standard deviation of the sample?
3.0.
3.9. Very good. That's your S. Over square root of, what's the sample size?
200.
200. Now let's compute for the t sub 0. What do we get from that? So again, we can use our calculator for that to plug it in here. Again, we're using classical method, but again, we can use StatCrunch for this as well, okay? So let's put it in here. What's that gonna be? What's that? 22.6, right? 22.6 minus 2.2 over, what's your S? 3.9 over, okay, square root. So once again, I'm gonna click on the tools in here, click on the square root of n. Our n is 200. Okay, so my T naught, I got that one to be 73.974. All right, so it just depends on how you're gonna round it off. But so far right now, we can put in here 73.97. Now, again, that's 73.97. And again, this is a right tail test. So going back to the problem. So going back to the problem. Okay, let's see it in here. Can we move it up on here? Thank you. So once again, what is this? A right tail test. So where's that right tail? We're gonna use this. Okay. So your alpha is what? 0.05. Your n is how much?
200.
200, very good. And again, if it's t value, then we're looking for what? The degrees of freedom, right? And what's the degree of freedom? That's always what? N minus 1, all right? So if you can recall the degree of freedom, that's basically just 1 less than the sample size, okay? And once again, if your t naught is somewhere here, then you reject the null hypothesis. But if your T naught is somewhere here, then you do not reject the null hypothesis. Again, this is for right tail. So for this case, what do? Let's use our T table. Right? So let me just go ahead and erase this one and look at our T table. What's this? Yeah. T table. Where's the T table? Here we go. If you look at your T distribution, what are we looking for? Your your degrees of freedom is what? 199. Okay, so and again, this T test is T table is for the right tail, right? And we're using the right tail as well. For the left tail, since that's T table anyways, you can do symmetry, so it's just basically negative, right? But anyway, let's look in here. Degree of freedom 199. As you may notice, there's no 199, but the closest is 200 basically. So we're gonna use 200 with alpha equal to how much? 0.05. So where is that? 0.05 alpha. What column is that? 1, 2, 3. Third column. Alright, so we're looking at third column with degree freedom 200. Alright? Also, as you may notice, if your sample size is too big, then your degree of freedom and sample size are basically almost the same anyway, right? So anyway, what is that? 200 degrees of freedom with alpha 0.05. And I think this is your alpha 0.05. Right? Third column. And your degree of freedom is in here. 199 is approximately 200. So that would be what? 1.653, right? So the T-score in here at 0.05, degree of freedom 199, approximately 200 is, how much is that? 1.653. So this is what again? 1.65. Okay. Now, where is our T naught? What our T naught a while ago is? What's the value that we got for T naught a while ago, guys? Let's check on the decimals. You know what? I forgot something in here. It should be 222, right? 222. There we go. There we go. 2.17. Yeah. So I didn't notice that there's a point in there. 22, right? My four eyes, sorry for that, what's that? 2.17, so where's 2.17? Somewhere, so if this is 1.653, we know that 2.17 is somewhere here. Kind of far, right? So we know that T sub 0 or T naught approximately 2.17 is somewhere here, which means, do we reject the null hypothesis? Yes, we do reject the null hypothesis. Okay, so once again, because it is far from the margin of confidence interval. Now, Mr. Deal, are we going to do that one every single time? Definitely not. Okay, so let's use our StatCrunch for this. So basically, we can use StatCrunch for that. So let's use that one. Okay. So there's a much simpler approach. Let's use StatCrunch. So don't mind this problem. Let's just use StatCrunch. Let's go here. Okay. So using StatCrunch, where do we go? Stats. Okay. Next to stats, where do we go?
T-stat?
T stats. Very good, very good. Again, proportion if it's qualitative, right? But if it's quantitative, T stats. Okay. Again, following all of the conditions and greater than 30, random sampling. Okay. One sample with summary. What's the sample mean? Again, a while ago that we got. I think it's 22 point something. 22.6. Thank you. Okay, let's keep in mind already the decimal point. Okay, because a while ago I put in 2.2. Okay, just be careful with that. Sample, standard deviation, what do we get? 3.9, right? 3.9. You may notice everything is given anyway in here. Sample size, how big is the sample?
200.
200, very good. So again, instead of confidence interval, we're gonna click hypothesis testing, okay? For population mean. And what's your population mean? It says 22. Okay. So again, my mistake a while ago, I put in 2 point, it should be 22, right? So mind those decimal. And see, and in here, again, this is for two-tailed. That is for left tail, the less than, and this is for right tail, right? So ours is what? Right tail. So that's greater than 22. Critical value, your level of significance is 0.05. And again, typically it's given. It can be 0.1, it can be 0.01, okay? Let's click on the p-value plot so that we can see that one as well. Click on compute. Okay, here it is. So, let's verify in here. What's our t statistics a while ago? We got our t not to be 2.17. Is that the same in here? 2.17, right? Similar to what we got a while ago, okay? Now, what's our what's our degree of freedom? 199, and we use that one as well. What's our critical value? 1.65. Did we get 1.65 a while ago? Yes, 1.653 from the table, okay? And once again, we used that one, a table a while ago. That is what? The T of critical value is where your alpha is 0.05. Again, that is for one tail, either left-tailed or right-tailed. But if it is two-tailed, then you're gonna cut it in half, okay? Yeah, if it's 0.5 or 0.05, it's gonna be 0.025, okay, for two-tailed. And what is the p-value? 0.0154, okay? Now what do we do then? After this, let's read our step number 4, okay, for this one. Emma, go ahead please. Yeah. Is
P value
less than alpha.
alpha.
Thank you, right? So what is our p-value? 0.0154. So is that less than alpha? What's our alpha again?
0.05.
Is it less than 0.05? Yes, it is. So yes, it is. So with that being said, then what do we do then? Step number 5. Brett, what do we do?
Conclusion plus interpretation.
Correct. So if the p-value is less than the alpha provided for us, what do we do? Do we reject the null hypothesis or do we not reject the null hypothesis? Reject. Very good, right? That's correct. So in here, as conclusion, typically those 3 dots meaning we conclude therefore that we reject the null hypothesis. Okay? So that means, what's the interpretation of that? That there is sufficient evidence to reject the null hypothesis, right? So there is sufficient evidence to, to examine further that the mean of the ACT math portion should be what? More than, right? The 22 a while ago, right? To what again? To further assess students to be what? College ready for college mathematics. Okay? Questions regarding that? Once again, this is for what? Right-tailed. Once again, also, if it's two-tailed, what are you gonna do with that? Cut it in half, right? Because if it's 5.05, there is 0.025 on the left and on the right, okay? But again, StatCrunch will help us out with that one, okay? Now, let's continue working in here and consider answering one specific question for this case, okay? Here it is.
I thought I had to do it.
Oh. You know, you can get rid of all those classes that you don't have right.
Educate me.
All right, so let's read this one and see how this one was answered in here. Let's read this one first. Question number, what's this? 4 on your end. Let's read it.
Thank you so much.
You're welcome.
Sydney, go ahead, please. In a study,
In a study, research wanted to measure the effect of alcohol in, what does that say?
hippocampal or something, hippocampal region. Where is that? I guess
Hippocampus.
hippocampus. Where's hippocampus? I guess it's in the brain or something.
Yeah.
Okay, thank you. Okay, thank you. Continue, guys. Continue, Sydney.
Question reasonable for long-term memory storage in
Adolescents. Okay.
adolescents. The research randomly
Selected.
selected 12 adolescents with alcohol disorders to determine whether that the hypo volume in the alcohol research were less than the normal volume of, I cannot see.
9.02 cubic centimeters.
And the analysis of sample data revealed that and the hypo volume is approximately normal and no
Outliers?
I cannot see, I'm so sorry.
Sorry. Let me continue here. X bar is 8.07 cubic centimeters, and S is equal to 0.8 cubic centimeters that conduct the appropriate test at alpha 0.01 level of significance. All right. So first of all, let's consider this flow chart in here. First of all, what is the parameter? What is being measured? The volume, right? The hippocampal volume, okay? So that means it's a what? Quantitative, right? So yes, we can do that one. Next, is there a random sampling done? Yes, there is, right? So notice the researchers randomly selected. So yes, there had been a random sampling done. But what is your sample size? Is your sample size greater than 30? No, it's not, right? So your N in here is 12, and we know that 12 is less than 30, right? So we cannot directly use t distribution yet. That's you. So what do we do next? Mason, go ahead. Is
the population a normal distribution?
okay? Did it mention that the population is normally distributed? Well, let's verify. Avi, let's read where that one came from.
Analysis of the simple data revealed that the hippocampal volume is approximately normal with no outliers.
Thank you. Right. So yes, there is a mention that the hippocampal volume is what? Normally distributed in the first place with no outliers. So yes, we can assume normal distribution in terms of its population. So in short, can we use t distribution? Yes, we can. All right. So let's do it. Let's do our null hypothesis and alternative. So we say in here that the volume mean for the population is 9.02. Okay, right? Now, it says in here what? What is the term in here? It says in here less than, right? That means that your alternative hypothesis is what? Less than 9.02. So what kind of test are we using? Left tail test. Okay, so left tail test, in short, if this is your t distribution, this is your t equals 0 on the left tail. So we can look at the TCV at alpha equals what? 0.01 level of significance on the left. And your degree of freedom is how much? 11. Very good, right? So if there's 12 adolescents as a sample size, less 1, we're considering 11 degrees of freedom, okay? You can use your table of values or use StatCrunch for such. Now, what is our T statistic and everything else? What do we do? StatCrunch, all right? Let's do StatCrunch for that. Let's click in here. Okay, let's go to StatCrunch. Okay, what do we do? Go where? Thank you, that's correct. Let us just erase this one first before we continue, okay? There we go. Just to clear this here. Yeah. I would leave this one. So again in here, oops, you reject the null hypothesis if it's in here, on this tail end, okay? But anyway, let's continue. Very good. Angelina, click on stat. Go to where? T, yes. How many samples? 1. With summary, very good. Okay, what's the sample mean? Did it tell us what the sample mean is?
Yeah, it's X.
Okay, 8.07 and 0.8 sample standard deviation, right? So 8.07, 0.8, and 12 adolescents, right? So I put it in there. Okay. 8.07. What is this? Did I say 0.8 a while ago? And what sample size? 12. Click on hypothesis test. What's our hypothesis? That it should be what? 9.02, right? That's the population mean, right? So I'm gonna go back in here. I put in 9.02. Left tail, so I'm gonna use what? Less than. And what's my critical value to be shown at what significance? 0.01. Okay, so let's click on this p-value plot and choose it in here. Okay, so there we go. That is, let me just move this in here just to clearly see this one. Okay. So according to this, what's my t statistics? My t sub 0 is where? Negative 4.114, right? So somewhere here, again, t sub 0 is negative 4.114. But what is my critical t? Negative 2.7. So basically this t critical value is what? Negative 2.7. And where do I place this one? Further to the left. Okay, so we know that t sub 0 is somewhere here, right? Somewhere far. Okay. And what's our p-value? It says to be 0.0009. Okay, which means how do we compare this p-value to? Where do we compare this p-value to? Alpha. Very good. Level of significance 0.01. Now, is it less than 0.01? Yes, much less than 0.01. Okay. So with that being said, what is our decision? What is our conclusion and interpretation for such? Reject the null hypothesis. Very good, Angelina. That is correct. It's on the area of rejection of the null hypothesis. Also what? There is sufficient evidence to support the alternative hypothesis that there is what? A lesser hippocampal volume for this case. Okay, so with that, again, there is sufficient evidence to support that claim. But anyway, but again, we don't directly accept that alternative hypothesis. We just say rejecting the null hypothesis. Again, rejecting the null hypothesis doesn't necessarily mean that we accept the alternative. But there is sufficient evidence to support the alternative hypothesis. Okay? So as you may notice in here, that's negative 4.11, 0.0009, which is 0.001. And yes, you reject a null hypothesis supporting, right, an evidence supporting that in fact the hippocampal volume is less than the population measurement, mean measurement, which is 9.02 cubic centimeters. Questions, guys? So basically that's it for our population mean hypothesis test. Honestly, you can use StatCrunch for the entirety of it, and then you might be asking, Mr. Deal, you click on that P plot a while ago. What does it give us? So if I click on the right side in here, that's basically this. Okay. So if you click on that, that basically tells us what we got in here in the first place. Okay. So where's our critical value? Our critical value is where? Negative 2.7. So negative 2.7 is somewhere here. Okay. PCV, negative 2.7 is somewhere here. And that's negative 4.1136. So yes, it's on the area left tail end of that T distribution, which means it's on the area where we need to reject the null hypothesis. Okay. Once again, if it's two-tailed, you're gonna cut that alpha in half. Okay, because it's the right half and the left half. And again, that is when your alternative hypothesis is not equal to however. Okay? Thank you so much, guys. So again,